Good morning, everybody. My name is Debbie Woodliff. I'm the Communications Officer for the EU-funded H2020 SECLI-FIRM Project. I'd like to welcome you and thank you for attending the first webinar in the SECLI-FIRM series. We're excited to kick off this inaugural webinar with Alberto Chocolate, our project leader, who will be giving us an overview of the project and discussing some of the preliminary results. This will be followed by a presentation from Dr. Claire Goodis, a Senior Research Fellow at the Climatic Research Unit at the UEA. This will explore the project's interaction with industrial users and the framework for assessing the value of seasonal forecasts. We'll then have a quick Q&A session at the end to get your thoughts and answer any queries you have, but feel free to submit any questions throughout the webinar via the control panel. We'll collect all these and answer as many as possible at the end of the session. Just a quick reminder that a recording of this webinar together with copies of the presentations will be available to view online at a later date if you miss anything or if you want to show your colleagues. So without further ado, over to Alberto.
Okay, thank you, Debbie, for the introduction, and hello, everybody. As Debbie said, I'm going to give an overview of the SECLI-FIRM project, which is the acronym for the added value of seasonal climate forecasting for integrated risk management decisions. Quite a mouthful, but it's quite an exciting project. So let's first of all acknowledge all the team members. There are many partners contributing to this project. You will see them throughout the presentation at the bottom. The project is led by UEA, University of East Anglia in Norwich, and we have former partners in Enel, ENER, Met Office, UL, KNMI, WMC, URAC, Alperia. The project is funded by the EU under the H2020 program, and the grant agreement is also shown at the bottom. So the presentation is structured in this way. So we'll show first of all the reason for the project and the rationale overall. So the why, how, and what of SECLI-FIRM. We'll then go through a selection of results by work package, and I'll tell you more about what each work package does, and then some brief summary and perspectives, and again briefly on what to look for in 2020 for SECLI-FIRM. So this presentation also, I should say, is pretty short compared to the material that is being produced by the project. So apologies if I go too quickly over some of the results, but you're welcome to ask questions at the end, or indeed also get back to us after the presentation so things can be discussed more at length. So why the project was put in place, or the proposal before that. So we had a colleague, a risk analyst called Jody, who had this problem, and this was that basically they noticed the production of hydropower, in this case was in Italy, was pretty low for a particular season, that was winter 2015-2016. So Jody was quite concerned because that meant that they couldn't produce enough hydropower for the following season, and but they didn't anticipate that because they didn't have enough information about the future of precipitation, temperature, and other climatic variables. So they were asking themselves, is the next season going to be very wet and you get a lot of production, like on the top right on your top picture on the right, or quite dry like on the bottom right? So that's something that is quite difficult to anticipate if you don't have the right tools, and that's why we started this conversation with Jody, trying to find out what could be done, and that's where the proposal started to take shape. So then We also talked with other people, of course, and found out that Jodi's case was not isolated, and several other people had similar concerns. And that's when we put together this series of case studies. So we got 9 case studies in the project. They represent recent seasons with anomalous climate conditions leading to problematic and quantifiable impacts for the energy and the water industry. They are mainly over Europe, but we also have a case or 2 over Colombia. And importantly, and as we will discuss with my presentation, but especially with the following one by Claire, this have been co-designed with industrial and research partners. Sorry, that went step. Okay, so overall, the 9 case studies are aiming to improve the seasonal climate forecast science applied to real decisions. That's what we are working on in the project. I should also say that the project started in February 2018, so nearly 2 years ago, and we are just over halfway through with an end in July 2021. Right, then what we thought is that we need to have a framework to find out how good this seasonal forecasts are. If we're going to use them, we need to work out their value. And the way to do it, after many discussions, again, Claire will explain better, but we basically had to go step by step through the decision making that the industrial partners or other users are going through. So that's when we ended up building a decision tree for each case study, and also a framework, like you see on the right-hand side, for evaluating the value of the seasonal forecast. And essentially what we do is we take a reference, which is basically what the users are currently doing, and then based on that we'll see what the decision is when the seasonal forecasts are used. So the differential would be the value. So quite simply, it's not straightforward in words, but in practice it's quite complicated actually. One thing, sorry, I forgot to mention here is that we do have industrial partners in the project, but on top of that, we also have some engaged stakeholders who are collaborating very closely with us. And although they're not official partners, they are very engaged in the case studies, as you can see through the logos represented there. I won't go one by one, but just suffice to say that each case study is formed by at least one research partner and one industrial partner at the very least. And then what we are at the end is a climate service for each of the case studies. In some cases, they are aggregated, so we won't have 9 climate services as such, but they will have different climate services, several of them. And this will have the aim to demonstrate how the use of improved seasonal climate forecasts can add socioeconomic value to decision making in the energy sector as well in the water sector. And we'll also look at the implications for other sectors once we get all the results as a final analysis in the end. Right, now going through the structure of the project, we got 6 work packages, and you see the depiction on the slide here. The important thing to note is work package 1 is at the center, and work package 1 is the first one that started and the one that is providing the glue between the industrial partners and science partners and all the case studies and the science work and also the production of the climate services eventually. So that's quite an important one. Of course, all the others are very important too, but the way we structure the project is that there is a lot of interaction across all work packages, as you can see, and that's what is happening in practice. Now, going word package by word package now. So word package 1, we said, is the first one that initiated a discussion between industrial partners and science partners. And there we went down to the nitty-gritty of each case study. I won't go into the details of this slide, but just wanted to show the level of detail we basically discussed at length, what type of variables are needed, what are the criticalities in the decision making, and what data we should download, retrieve for seasonal forecast. So from a wide range of topics, from the decision making process to the data that we actually need to achieve a better decision using seasonal forecast. And then on the other hand, still in work package 1, we looked at what is available in terms of assessment methods to work out how to quantify the decision making with the seasonal forecast, and how we can find out whether seasonal forecasts add values or not. So we got a kind of menu which tells us all the available tools, and that's important because we got different case studies that address very different questions. And what we don't want to do is to preempt the answers with, say, taking one specific methodology and apply to all of them. Rather, we want to discuss and see which one fits better each case study. And that's, again, what we are doing, what we've been doing. And Claire will tell us more again on this. Now I switch to the other word packages, more kind of technical one. Word package 2 is on the research component. So the word package 2 does the optimization and exploitation of seasonal climate prediction performance for key climate variables considered in the 9 case studies through a range of approaches. And so we got, again, a portfolio of research approaches like we've done for the methodologies to assess the value. We also do something similar for the options to that we have from the science output to address the various case studies. So we provide a number of options, and then we see which one is most applicable to each case studies. Of course, we got already quite a good idea of which kind of solution works for each case study, but we also keep things flexible in case we observe that something may work better with methodology rather than another. First thing was to collect all the seasonal forecast data, and one of the main aim of the project is to work on multi-model and not just the well-known C3S now. So the Copernicus Climate Change Service is providing 5 models, soon 6 also, NCEP. But we also wanted to adopt other models because of the diversity they provide. And so we ended up with, at the moment, 11 models. And this is the compilation of models without going into the details. Each one has their own characteristics, whether they are the ensemble is generated by burst, lagged, mixed approach, and various other things. So without going to the detail, you get the slides also at the end. You can go through this. Just to say that we got quite a large set of output that we are working on, and we want to exploit as much as we can during the project. Some of the results for package 2 regard the performance of seasonal forecast, in this case for wind and temperature, where we assessed the brass skill score for the lower tercile. Again, I won't go into the details, there's not enough time here, but if you're interested, please get in touch. So you'll see we're comparing models with one another, and that demonstrates that there is a good, there's benefit in using different models. And we also introduced a new metric, which is called probabilistic independency. And that, again, demonstrates the differentiation that there is from one model to the other. And we are using this metrics also to establish how we should use one model versus another when we combine them. Sorry again, skipped one. So of approaches that we used in, sorry, that should say work package 2, apologies, but this is weather types. So one of the approaches we use in work package 2 in this research part is the weather types, and there are, this is applied particularly to case study 8. And the reference in this case is an observational climatology. As I said before, we need a reference in order to work out the value of the seasonal forecast. So here is climatology. In most cases, is a climatology. And the aim here is to produce a shifted and scaled distribution for the winter representing the forecast climate. We use daily mean sea level pressure from forecast, and from them we come up with a sequence of weather types during the winter, and these are used against the observed wind, and the response to the weather types gives the wind forecast. The method works in principle for wind and mean temperature and also precipitation, but in practice the model, the system that has been tested, which is the Met Office GLOSY 5, only has skill in the NAO-like weather type. So number 1 and number 2, you can see here at the top. And the skill is limited to wind speed only. And for now, it's no better than using NAO itself. And we'll have to see when we start to then look at also other models and comparing them, and see whether the skill improves somehow through the multi-model combination. So this was the work package 2. Now, moving to work package 3, this is just again a different representation of the case studies that I showed at the beginning, and particularly the subdivision, how we have structured them in terms of case study 1 and 3 are related to events happened over Italy. 3 and 4, Spain and Colombia. 6 over the North Sea, and 7, 8, and 9 between North Sea and the UK. And again, you can see all the partners and stakeholders, users involved in the case studies. We've done quite a lot of work here to discuss, first discuss and then implement the use of probabilistic forecast. As many people know, is often something, a difficult thing to adopt, the probabilistic aspect of a forecast, such a seasonal forecast. But I think we have now achieved quite a good compromise with the use of probabilistic forecast. And we also use here during the case study implementation what we learned during work package 1 discussion around decision trees, because that's also what is providing the thresholds for decision thresholds. So that goes hand in hand with the probabilistic approach. And then we also do development of tools to produce tailored data. So one thing to understand here is that because of the specific nature of the case studies, we really need to adopt something that is specific in order to get the most out of the forecast. So we start from something rather generic in work package 2, but soon we need to go and be quite specific in what we do, because we need to align the work in work package 2 and with work package 3, and that's what the tailoring is about. We also looked at application of climatic indexes and computed, for example, the standardized precipitation index, which will come also on the next slide. So in the middle, for example, you see the precipitation index I just mentioned, and it's being calculated for December 2015, which, if you remember, this was the season when our colleague Jody was quite concerned about that dry period, and indeed you can see that actually the colors go off scale in the north of Italy, where we had a deficient production of hydropower due to low precipitation. On the left-hand side, the plot relates to case study 6 and the studies on wave regimes over North Sea, and particularly in this case, we've been looking at the climatology and how forecasts compare to climatology to see how the forecasts, how they deviate from climatology for specific cases. Then on the bottom, we are looking at case study 5, which is hydropower in Colombia. And in this case, we are adopting the approach of the ENSO regime. So we're using El Niño Southern Oscillation as the main indicator to start with, because of course that provides a lot of predictability for that region of the world, unlike for Europe. And then on the right-hand side, on the top, we got some of the work that has been done to tailor the information from work package 2, and specifically for case study 1 and 3 here for the Italian domain. And at the bottom is the tailoring technique used for energy demand for case study 8 for the UK. Okay, as I said, I won't be able to go into much detail at all, but I hope this gives you a flavor of what's been achieved and what we're doing in the project from a seasonal forecast and application perspective. Now, looking forward, the work package 4 is the one which then brings together the lessons from work package 2 and 3 and builds the actual climate services, which we call trial climate services. So they are meant to be as close as possible to an operational system, but we want in the project achieve an operational system. But what we are doing is trying to get as close as possible to it, so that after the project, this climate services can be further exploited by partners or other people interested. And for that, I will mention it also later, we have stakeholder workshops open to any other person interested in discussing with us what we are doing. In this particular case, and work package 4, so this is initial thoughts. You see on the right, we started to plan things and put into a schematic what is required for each case study. That's a very useful table that describes what whether a case study requires a visualization tool or a raw data, post-process data, guidance only rather than the data, for example. So through commentary, something like a fact sheet or a bulletin or things like that. So more formally, the visualization is required across multiple work packages of case studies. So case study 1 to 4 together and case study 6 and 7 together have some need for visualization, which is at this stage unspecified, but we are now working on the specifics of this, what this visualization should look like. And importantly, also, we want to bring together the other components of the project, like the decision tree, and we want to incorporate this, all this thinking about how a decision is reached within each case study, within the climate service that we provide. So all case studies incorporate some form of post-process data. And fixed guidance note to accompany forecast could limit human involvement, and it therefore needs to be integrated with decision trees, understanding the range of decision makers' expertise, learning material around reusing complex graphs, and it needs to be co-designed and delivered through training. So in such a way that, for example, users need to be comfortable in the use of probabilistic information. And so, as you can see, we're not looking at something that is fully automated. It's always going to be a human component in the use of seasonal forecast, whether it's through a visual tool or through the provision of data only, that the human aspect needs to be there to provide guidance. And so in terms of what we're currently working for work package 4, we are identifying, clarifying the method and style of forecast delivery. And this is done in a full co-design approach with the case study partners. And by the way, the co-design, I hope that has come across during the previous slides through. This has been the leitmotif of the project. So the co-design and co-development is key to the project, and the project couldn't have achieved what has achieved without this. And that's a very important aspect that will be discussed more later. So thinking about how to incorporate learning from decision tree into trial climate service is also the other aspect we're looking at. And we also are recognizing and taking stock of the IP produced by the project and how this can be used in the transition from research to operations and commercial opportunities I mentioned earlier, when we go from the end of the project to the follow-up after the project. Structure of the first task in work package 4 is that there is a decision process, delivery tools, application platform, visualization. We are identifying obstacles and contingencies, and evaluation process and work plan. And importantly, as I also mentioned earlier, we're holding a stakeholder workshop on 14th of May 2020. I'll repeat it again later. This will be in Brussels, but if you like to take note for now, that be the next opportunity for wider stakeholder community to interact with the project. And there we will present the status of the prototype service, the trial climate services, but we also seek feedback on the co-design process and where we will be at that stage. Okay, so that was work package 5. A few words very briefly on work package 5. I am a bit over time, but bear with me. So I've got only a few slides left. Work package 5 is about the communication. So, sorry, the previous one is about the videos that we produced. So far, we got two. The latest one is the one about case study 7, and this is actually very important because it came about from a conversation with our advisory board, and the recommendation was to produce a video that allows people working in the project to communicate what we do with the management within each company. And some of the companies, and actually most of the companies we're working with, are quite complex, and so there's a lot of hierarchy, and that's where videos like the ones we produce, so we hope will help with the communication and trying to convey the importance of what the project is doing. And we'll produce each a similar video for each one of the case studies. Then we have stakeholder workshops, news items, newsletters, social media, and partners interviews, all on our website. I provide the links here, but there's more. Please visit our website. So just to summarize, conclude, take stock of what we've done and what we have in the project, so that it's useful to remember that for if you want to remember anything about the project, these are the key SECLI-FIRM elements of our project. And so I lost the mouse. Okay, so we got the first element is the multimodal combination of seasonal climate forecast to enhance the forecast skill for specific industry user-defined questions. And the second one is the case study examples of the quantified economic benefit to assess the added value of seasonal forecast. The third one is the proof of concept of climate service or trial for potential post-project adoption on a commercial basis. Just briefly on lessons learned so far, we had challenges as in all projects, but this have been tackled quite successfully. And here we just explain, I think this provides also a nice segue for the talk by Claire, because a lot of this is to do with the interaction between research community and the industry community, and that a lot of lessons have been learned here, and we overcome a lot of obstacles, and I think we achieved very good results in this respect, and we laid the ground for quite an exciting project ahead for the remaining of the project. So expectation and terminology in interdisciplinary environment has been a challenge, but we developed an effective framework for exchanges between scientific community and users. Development of a comprehensive multimodal data set also has been a challenge. This is more technical, but we reached a pragmatic compromise between initial requests and technical limitations. Actually, this also had a component of, wish list of things that were not quite achievable, and then we had to scale down because that's in practice we couldn't, for technical or cost reasons, we couldn't achieve that. And then the last one is the matching the appropriate science with individual case studies. And again, here we enhance the fertilization across scientific tasks and case studies with a broad portfolio of solutions. Right, so the last one is what to look for in 2020. I mentioned before, we'll have a new partner starting soon in Meteor France, so we're quite excited to welcome Meteor France in the project, even if at a later stage, but there's still a lot to do, so it's very good to have Meteor France on board. And we'll have a stakeholder workshop, as I mentioned, Brussels, 14th of May 2020. During 2020, we'll finalize the case studies based on probabilistic seasonal climate forecast and evaluation of their value add. And we'll also have an advanced development of climate services trial. So sorry it's taken a bit long, but it was quite a challenge to squeeze in all the material. And as you could see, I couldn't discuss most of it. So please get in touch if you want to learn more about SECLI-FIRM. Over to you, Debbie Claire. Thanks.
Thanks very much for that, Alberto. We'll move quickly over to Claire. Claire, if you're ready to get going on your presentation.
Okay, thank you. Okay, hopefully everyone can see my screen now. So, good morning, good afternoon, and it's a great pleasure to have this opportunity to talk to you about the interaction with industrial users in the SECLI-FIRM project and the framework that we're developing for assessing the value of seasonal forecasts. Just to remind you that you can type in questions as I talk, either on my talk or on the previous talk by Alberto, and we'll come back to those at the end. But before I get on to the topic of the details of SECLI-FIRM, I'd like to step back for a minute and talk briefly about some of the broader issues relating to development of climate services. This is quite a complex figure, but it relates to the experience of a number of the SECLI-FIRM team members in developing a pre-operational climate service for the energy sector, the ESEM service, as part of the Copernicus Climate Change Services. And this diagram comes from a paper that we published at the end of last year that you can go to for more detail. But I just want to highlight what we identified as some really important aspects and issues if one is really serious in terms of co-designing and co-producing climate services. And the kind of most obvious thing is the need for partnerships between the producers of climate service information and the users of that information. And that these partnerships need to be kind of developed right from the onset. It's not something that happens right at the end. It's also quite a kind of slow process. So in ESEM, we were probably two years or so in kind of moving to this position here of having a successful proof of concept of pre-operational climate service, and further work is ongoing in developing the community of users and target users, now developing an operational climate service. And some of the things that SECLI-FIRM is doing were really highlighted as being important in our work in ESEM, so particularly the importance of developing tailored data, quality data that is usable and information that is usable for the particular application on which the climate service is focused. And so the work that Alberto highlighted in Work Package 2, for example, is really important here. But climate services is also, it's not just about sort of pushing information that comes from the providers to the users. It's also about the sort of pull, it's about developing the demand, which is essential in order to have a well-developed market for climate services, in our case for the energy services. And this is where kind of where SECLI-FIRM comes in terms of our work on value add. In ESEM, we were sort of developing a service that was focused on the energy sector, but nonetheless was sort of fairly generic and not necessarily going down to the final end user. And so we still saw scope for developing commercial products and services of what we were producing and what is now being produced in C3S Energy. Whereas in SECLI-FIRM, we're really focusing on trying to assess the value for decision making. So questions like, by having information earlier, by having better information, by having good seasonal forecasts, can businesses save money, for example? And so because we are focusing so much on the sort of specific decision-making context, that more generic approach that we took in ESEM is not so relevant. And it's why we're taking this case study approach in SECLI-FIRM. So as we've heard, we have these 9 specific case studies that were actually identified at the proposal stage, even before we embarked on the project. Okay, you've seen this figure before from Alberto, but again, to stress that our case studies from the outset have been co-designed, were identified by industrial and research partners, kind of working together, and they're being co-produced and implemented on this joint basis. So, for example, the anomalous weather events, the extreme events that are the focus of most of the case studies, the specific events, they were actually identified by the industrial partners rather than the research partners, whether those partners are in the energy or the water industry. So again, you saw a slide like this from Alberto, but and it highlights again, it identifies again in bold the coders of the industrial partner involved in each of the case studies. So for example, case studies 7, 8, and 9 have the Met Office as the research partner, but working with different industrial partners. So Shell, National Grid, and Thames Water. This table, it's a sort of condensed version of much larger tables that we've produced to try and go into more detail of each of the case studies. Again, it highlights the specific climate events that are being focused on. So, for example, this is the dry winter of 2015-16 that Alberto mentioned, and highlights the sectoral impact that we're focusing on, whether that's generation and sort of demand balancing, whether it's offshore operations and maintenance. Now, although each of these case studies is very specific, focusing on specific events, specific sectoral impacts, and particular industrial partners, we still wanted an overall sort of standard framework for how we assess the value add. And this is the very broad kind of framework that we've identified, that Alberto has already shown, where we have this control or this baseline case, which is maybe kind of what happens at the moment, where perhaps just using a 30-year climatology, the industrial partners make a decision, often using their own in-house models. They make the decision and have the outcome in terms of economic returns, for example. So what in SECLI-FIRM we're trying to do is the industrial partners would go through the same sort of decision-making process, still using their own in-house tools, but importantly, they will be taking tailored seasonal forecasts from SECLI-FIRM. And by comparing the outcomes of these two different extremes, this will give us an indication of the economic value of the seasonal climate forecasts. So as Alberto said, we started 2 years ago, and this the starting point for the different industrial partners was somewhat different, but certainly in terms of the energy companies involved in the project, most of them were using climatology, so 30-year averages, for example, or using fairly simple stochastic approaches to their use of climate information, and weren't really using seasonal forecasts in any way. Had very basic, limited knowledge of the about how to use climate information, information about climate variability, and had either no or very basic knowledge about the existence of seasonal forecasts, other climate data sets, and sources of information such as the Copernicus seasonal forecasts. So over the 2 years, it's been quite a slow process in building relationships and understanding terminology, developing a common language. But this is slowly built over the 2 years. As Alberto said, a lot of this has come through the work package 3, where the case studies are kind of being now applied following the framework developed by work package 1. But probably this arrow should be 2 ways to work package 2, who are developing the tailored climate, the tailored seasonal forecast. And so gradually work package 2 is learned from work package 3 and vice versa, and not just with the SECLI-FIRM team members, but bringing in more of our industrial partners from the case studies. So I think now good progress has been made. Many of the stakeholders or the industrial partners had very much a sort of deterministic mindset, thinking about how to use single numbers relating to climate. And now I think are beginning to kind of understand why it's important to move to at least a semi-probabilistic approach and how that can be applied to their business evaluation models. So yes, it's been slow. I think we kind of knew that from ESEN, but after 2 years, we're now making good progress. So Alberto mentioned that we've been assessing economic assessment models for how to value climate services. We actually brought in an economist from the University of East Anglia to do this work for us. These are the 6 different types of methods that have been identified. This is building on work that's previously been done in the Horizon 2020 CLARA project, and also Horizon 2020 has a task force on the value of climate services, and SECLI-FIRM is contributing to that. Also a previous nice review on methods that was published in Wire's Climate Change. I think one thing that this review and the work that Nicholas has done for SECLI-FIRM kind of shows that actually not so much work has been done for the energy sector. A lot of the examples in the literature are for the agricultural sector. But so we have a number of different methods, some of that an understanding now with their advantages and disadvantages. So for example, methods like decision theory models that include cost loss models, for example, they're relevant where a business is making a decision that isn't affecting anybody else. But some of these more complex models, so general equilibrium models, they are maybe more relevant where a decision can have wider implications for the sector. As Alberto said, we're now at the point of the case studies. The different case studies are considering these different methods, working with Nicholas, with our economist, thinking about which are most relevant for them, and considering the relative merits of these different approaches for their particular case studies. And this whole process has been facilitated by the use of decision trees, which we see as having a number of advantages. So they illustrate the key decision processes for the individual industrial partners, focusing on the climate-driven ones. But of course, they're not only thinking about climate and making their decisions, but really importantly, these allow us to identify the points or the nodes in the decision process where SECLI-FIRM data with seasonal forecasts can be embedded and its value assessed. So this is this process began a year ago, almost exactly a year ago, when we had a workshop in Milan, and we this was a bit of an experiment, but in the workshop we put two of our industrial partners from TenneT and from the North Sea literally on the spot, and got them to explain to us in more detail their decision-making processes, while at the same time a colleague of ours, Lauren Dubuis, actually drew the processes that they were describing in real time. So these are two case studies involving TenneT and North Sea that involve operations around the maintenance of off-sea structures in the North Sea, decisions about when to hire vessels. So this is the drawing that Laurent produced for us at the end of the workshop, and we can see that a bit better here. We've transformed it into a PowerPoint, so a bit easier to see. So to say, these two case studies are focused on maintenance of offshore structures. Currently, vessels just tend to be hired in the summer months, because on the basis of climatology, the companies think that the conditions, particularly in terms of wind and wave conditions, are appropriate. But if the companies could hire vessels in advance, or also could confidently hire them for the shoulder seasons in spring or May, then it would be cheaper to hire the vessels. So this is the decision tree, the generic decision tree that we have for these two case studies, showing the importance of wind and wave conditions. So now seasonal forecasts are being developed for wind and wave conditions, and which will tell the companies about the probability of exceeding particular thresholds, and then the decision to go or not will go ahead. So currently more work is going on and on delving into even more detail on these case studies and putting numbers in place. The second example of a decision tree is one that this relates to this issue of dry winters in northern Italy and hydro generation from reservoir systems. And this comes from the industrial partner Alperia. And this is their modeling chain, where they have a long-term model, which then feeds into a shorter-term model of generation of production, and then into their economic assessment of price, storage management decisions, and ultimately profits. So this is currently how Alperia work, the climate information that feeds into their long-term model. So historical information about the energy market prices, the actual water levels in the reservoir, and historical data inflows then feed into the long-term model, giving them information about storage management options and the longer-term energy production. What they want to do in SECLI-FIRM is to replace this historical information about inflow with the forecasts, with the seasonal forecast models, in the hope that this will allow them to improve the management, the annual production of hydro, and consequently the hope that the final profits may increase. And this is what we hope that we can actually put some numbers on. So that was a kind of fairly quick kind of run through what we're doing in the case studies, how we're working within the case studies, the kind of motivations. If you want to know more, go to the website. This is the first set of case study flyers. We'll be updating these shortly. As Alberto mentioned, we have a nice video.
And you can also visit the SECLI-FIRM website at www.secli-firm.eu for more information about the project, for more case study videos, for more case study flyers, and more information in general about the project. Thank you all very much for attending, and we'll see you next time. Yes, thank you very much for that, Claire. That was really nice and informative. We'll just open the floor out to some questions now, if you've got any. If there's no questions, we'd just like to thank you again for attending, and we'll let you know what the next webinar will be in due course, and we'll send out communications nearer the time as well. As you can see, we're on social media, on Twitter at SECLI_FIRM, and we're on LinkedIn as well. So please follow us to stay up to date and to find out when the webinar recording will be available to view and when